Okay, this is the second video on linear equations, second order. Let's start 6x minus 2 equals 4x plus 8. Now the first thing you're going to notice is that we've got more than one set of x's. Don't worry, the same principles apply. So let's go. I want to get all the x's on its own on one side. Same thing. We're going for the same thing. All the unknowns, one side of the equals, all of them, nothing else. So let's get rid of this 2 first of all. To do that we must add 2, do the opposite. So 6x, take away 2 plus 2. Whatever we do to one side we must do to the other. Plus 2. That becomes 6x equal to 4x plus 10. Fantastic. Now, this is where I want you to sort of step back and have a think about this. We want all the x's on one side. So there's two ways you can go about this. The way you think, I mean. This process is what happens is the same, but the way you think about it. If I was just looking at it, I'd say, well, really, I want to get this lot of x's over to this side. I mean, it's quite nice to visualize. I want to get all the x's on one side. Now, that isn't actually what we've been doing with regards to getting rid of elements on one side. We've been doing the opposite operation to get rid of them. So, bear with me on this. I'm going to say I want to subtract 4x from both sides. So I'll say 6x, take away 4x, equals 4x, take away 4x, plus 10. And you can see that becomes 2x is equal to 10. But let's just hold it there. If you didn't like that, if you thought, why am I taking 4x away? Well, you're doing it so you can have all the unknowns on one side. Alright, you don't want the unknowns on this side, so you do the opposite. There's a 4x there, I want to get rid of them, so I take away 4x. There's another way you can think about this, and it's totally up to you how you go about it. You could say to yourself, well, actually what I'm doing is I'm picking up the 4x and I'm taking it over to the other side. But the rule is, whenever I take something over the equals, if you can imagine it's like a force field, the signs change. Okay? So if you're saying to yourself, well, I know what I'm doing, I'm saying this 4x here, I'm going to take it over to the other side. So I pick up 4x from this side up here, and I take it over the equals, and bang, it goes through the force field, so it has to change signs, which is what has happened here. In fact, I'll show you up here, give you a better idea. So I'll do it in black. It's 4x here equals 6x, I think it was plus 10, yeah. And we're going to take the 4x over. So as we take it over, the sign changes. So we end up with 6x take away 4x, leaves 10. Because we've taken it over, we've just literally moved it. Now, that is one way to think about it. I personally would encourage you to look at it in the whatever I do to one side, I do to the other format, and always think I want all the unknowns or all the x's on one side. So if I end up with x's on the wrong side, I have to get rid of them. So I've got 6x's on this side, I've got 4x on this side, I don't want the 4x on this side, I want to get rid of it. How do I get rid of plus 4x? Well, I take it away, minus 4x, and I carry it through. Alright? I'm going to leave it up to you. It's a personal preference thing. But this is a good habit to be in. Right then, after that little talk, let's get back to the sum. 2x equals 10. Well, we know what we're going to do here, don't we? We're going to divide through by 2. And I've skipped a step there. This is what happened. I'm sure you can see it. But we will end up starting to stop writing every single step. We'll start jumping a few steps when we get more comfortable. But for the moment, I should have written that in. I do apologise. So we have x is equal to 10 divided by 2. So x equals 5. Okay? There we are. You probably see that a little bit better. Fantastic. Okay, let's go on to a second example. We have here p over 2 plus 3 equals 7, or p divided by 2 plus 3 equals 7. So, first things first, I don't like this. I don't like this plus 3. What can I do? Well, we all know what we can do. We can take 3 away. So p over 2 plus 3, take away 3, equals 7. Whatever we do to one side, we must do to the other. Take away 3. So that becomes p over 2 is equal to 4. Fantastic. Okay, now what are we left with? Well, we're left with p divided by 2. We want to get rid of that divided by 2 because we just want p on its own. Okay, we want p on its own, the unknown on its own. So we know the opposite operation to division is multiplication. So we got to times through by 2. So we times through by 2. So p over 2 times by 2 equals 4 times by 2. Whatever we do to one side, we do to the other. This simplifies I should say. And we have p is equal to 8. Fantastic. As a mathematician, we are going to check. We always want to check. P over 2 plus 3 equals 7. Well, let's substitute that in. Let's say 8 over 2 plus 3 equals what? Well, 8 over 2 is 4, plus 3 equals 7. Fantastic. You got it right. P is equal to 8. Brilliant. One last quick example, just so you can feel really confident with the exercise that you're going to have to do in a moment. Alright, let's get this down. P plus 3 all over 2 equals 7. Okay, so this time it's p plus 3 all over 2. So 2 is to be you divide p and 3 by 2. So this time we've got to start with this 2 here. Alright, this 2 here. We can't start by saying, alright, let's just take 3 away, because actually this plus 3 is involved with its own division. Alright, it's plus 3 take away 2. I mean, you could write this as p over 2 plus 3 over 2 equals 7. And these two things are exactly the same. So in maths sometimes we just join this line up and put 1, 2 underneath just so it's easier to write. So we can't quite get rid of this plus 3 yet. So we've got to start with the division by 2. So the opposite, of course, is multiply by 2. So p plus 3 times 2 over 2 equals 7 times 2. Brilliant. Okay. Oops, sorry, 1 second. Move that up. So these simplify. Brilliant. So we have p plus 3 equals 14. That's much better. We can handle that. We're going to take 3 away because we have to get rid of this plus 3. So p equals, oops, sorry, I should have, I've skipped a step again, getting ahead of myself. P plus 3, take away 3, equals 14, take away 3. Bro. And we can do that. We can say, well, p is equal to 11. Fantastic. Let's check that. Let's check to see if we're right. So it was p plus 3 over 2 equals 7. P is 11, or so we think, plus 3 over 2 equals 7, equals something. We have to check, remember, we're not just putting that in. Right then, so 11 plus 3, we know is 14, divided by 2. Why are we doing that first? Well, because we have to treat that as though it's in brackets, alright? You always got to complete the sum above or below the division sign before you do it. So 11 plus 3 is 14, divided by 2. Well, yes, that does equal 7, which is what we said. So, big tick, excellent. P is equal to 11. Well done. Go over these, and then have a go at the worksheet.